Hello everyone, today I gonna show you how I made my project for digital logic design course. So I made a simple converter that convert binary number into decimal numbers using IC74LS48. So these are the things you will need to make a binary to decimal converter. You will be needed one piece IC74LS48 and one piece 7-segment LED display. I used common cathode, one piece breadboard, one piece 9V or 5V battery. I used 9V, and about 30 pieces of wires. So this is IC74LS48, and here the pins of IC74LS48 decoder. Pin number 7, 6, 2 and 1 are for the input A, B, C, D respectively. VCC is for the positive side of the battery, that means 9V, and GND is for ground, that means the negative side of the battery. And pin number 9 to 15 is for 7-segment display. These are the output. This is the circuit diagram of my project BCD to decimal converter. So as you can see in the picture, here is the circuit diagram, and as you can see in the picture, A, B, C and T, that means pin number 8, 7, 2 and 1 are the input that come from the switch. Pin number 3 and 4 will be connected to the positive side of the battery, that means same as the VCC. And pin number 5, that is RBI, will be connected to the ground. And from 9 to 15 the outputs will be connected to the 7-segment display. There are 7 pins for A, B, C, D, E, F, G, and that these pins will be connected respectively A to A, B to B. And you can see the pin number 13 is for A, pin number 12 of the IC is for B, pin number 11 of the IC is for C, pin number 10 to D, pin number 9 to E, pin number 15 for F, and pin number 14 for G. There are also 2 pins left in the 7-segment display. Among them, GND will be connected to the ground, that means the negative side of the battery, and DP, that means decimal point, and this pin will not be connected to anywhere because you will need to connect this pin to another if you want to use 2 display. So I used 1 display, so I don't need to connect these pins to anywhere. So this is my project circuit setup, and now we will see the demo how my project works. So let's go see the project. So this is how my project look like. I'm really sorry because of this is a real mess of wires and it's really hard to see the pins of IC and display, but I hope you will clearly understand what you have to do by watching the circuit diagram part of the video. So what I have done here is basically I connected 2 of the pins from each switch to the battery, positive and negative side, and 1 output will come from each switch that will connect it to the IC's pin number 7, 8, 1 and 2. IC's pin number 3 and 4 will be connected to the positive side of the battery, that means same as VCC, and pin number 5 of the IC will be connected to the ground, that means same as pin number 8. Rest of the pin of the IC will be connected to the 7-segment display, and you can see the sequence in the circuit diagram part. So this is the circuit diagram setup. Now I will connect the battery to the breadboard. I will connect the positive and negative side pin of the battery to the breadboard's positive and negative pin. You can see since all the switches were given 0, so the decimal output in the display is 0. Now I will show you the other outputs by giving the inputs through the switches. This converter will show you from 0 to 9 because there is only 1 display. So if you want to convert larger number, so you have to add more display in the breadboard, and then you will connect the DP point, the decimal point pin of the display, to the other display. But for a single display project you don't need to connect the DP point to anywhere, that I already said before. So this was my project, binary to decimal converter. That's all for today. Stay well, stay blessed. Thank you.